let's start our topic. Okay. Good evening to all of you. This is chemical bonding day number 3. Here we are going to discuss about the first theory that is proposed by G.N. Lewis and Kossel in 1916. Right. Okay. So before that, already discussed about the electronic dot structure. Electronic dot structure. Already I gave the homework to you also. So uh, what is electronic dot structure? We call as EDS, or it is also called as LDS. So what is this EDS or LDS? EDS means electronic dot structure. LDS means Lewis dot structure because this is suggested by G.N. Lewis. That's why it is called Lewis dot structure because this represents the valence electron in the atom which are participated in the bond formation, which are participated in the bond formation. So G.N. Lewis, what he suggested that because most electrons are not participating in the bond formation, so what is the use of representing them? There is no use. There is no use of representing them. So it is better to represent only the electrons which are participated in the chemical bond formation. So who participated in the bond formation? We observe that whenever a certain amount of energy is provided to the atom, the outermost electron only jump. The outermost electron only ejected out from the atom, not the innermost. Because whenever you provide this energy so that the innermost electron will jump, sometimes the object may burn. Sometimes the object may burn because that amount of energy is sufficient to ignite the object. Ignite the object. That's why the electron ejection not possible at all. Instead of electron ejection, there the substance will burn. The substance will burn. Right. Okay. So EDS or LDS represent the electronic dot structure or Lewis dot structure of the atom. So what this is? Now this is nothing but either you put a dot mark, this is a dot mark, or you put a cross mark. You put a cross mark around the symbol, around the symbol. So this is your let us say NA, right? So around the symbol either you put a dot or a cross mark to represent the element. So these dot and cross marks are called as valence electrons. So I am writing here VE. VE means valence electrons. Valence electrons. So what a valence electron already we discussed already that there are so many cells are present within the atom. One is called outermost, one is called innermost, one is called penultimate. The outermost cell of the atom is called a valence cell. We call it as a valence cell. So what is valence cell? The outermost cell of the atom is called as a valence cell. And the electrons which are present in this outermost cell or valence cell, these are called as valence electrons. Right. So if you observe the electronic configuration of 20 elements, I can write here first hydrogen, single dot, helium, two dot, lithium, one dot, one dot, right? Okay. Beryllium, two dots, boron, three dots, boron, three dots. Okay. Then carbon, it has four dots or four electron in the outermost. Okay. Carbon, nitrogen has five dots or five electron in the outermost. Right. Oxygen is a represented. If I'm using cross mark now, I can use six cross mark. I can use around the oxygen. So this is also a Lewis dot structure. Okay. Fluorine. I can use a seven cross mark. Seven cross mark I can use here. Right. Because 7 electrons are present in its outermost. Then your neon. So neon has 6, how many? Sorry, not 6, 8 electrons are present in the outermost. Right. So I can draw your 8 number of dots here. Now sodium. So sodium again has a 1 dot because it has one valence electron, that is 3s1. Okay. Next, sodium, magnesium has 2 dots. Next, aluminium, that has 3 dots. Right? That is 3 dots. So you can keep in your surrounding of aluminium. Then silicon has a 4 dots, has a 4 outermost electron. Next, phosphorus has a 5 electron in its outermost. Sulfur has a 6 electron. So I can use here cross mark. I can use. I can put a 6 cross mark like oxygen. Next, chlorine. So chlorine has a 7 electron in its outermost. So you can put 7 cross mark. Okay, argon. So argon, so here has how many? 8 electron in the outermost. So you put 8 dots around it. Right? Okay. Now coming to potassium. So potassium, single dot. Your calcium, 2 dot. Calcium, 2 dot. So like that, 20 elements you can draw the electronic dot structure like this. This structure we call as electronic dot structure or Lewis dot structure. Now you observe which are chemical in it. Now you can observe here helium. This is what. Next is your neon. Next is your argon. So these are chemical inert gas. Chemically inert gas, helium, neon, and argon. What you are observing about the structure? So you are observing that either they have 2 electron or 8 electron in the outermost, in the outermost shell. Right. So achieving of so because of this presence of 2 electron or 8 electron in the outermost, so this configuration we call as, what is this configuration we call? So if it has a 2 electron in the outermost, we call it as a duet. What we call it? A duet configuration. Duet configuration. D-U-E-T. Duet configuration. And if 8 electron in the present in the outermost, it is called octet. OCTET. It is called octet configuration. Octet configuration. So all want to achieve that configuration, either duet configuration or octet configuration, in order to achieve the stability. Because already we discussed in our previous class that why atoms combine, right? So we discussed that chemically lower species or the chemical species which has a low energy, they are more stable. That's why your molecules are more stable than atoms. Moreover, atoms are less stable. Why? Because of their configuration. Because of their configuration. Because periodic classification is saying that, or periodic law is saying that the physical and chemical properties of the element are the periodic function of their atomic number or electronic configuration. That means the chemical stability of the atom depends on the electronic configuration. What is that magic configuration? Now, either 2 electron in the outermost or 8 electron in the outermost. 2 electron is called duet, 8 electron is called the octet. So everyone wants to achieve that configuration. Now, another question we kept there that why water has why the water molecule, why the water molecule has a symbol or a formula is a H2O, not HO2. Why not it is? Why not it is? Similarly, your sodium chloride, sodium chloride. So why sodium chloride has a chemical formula that is NaCl, not NaCl2, NaCl2. So today our topic of discussion will be this only, which is our the theory which is prescribed by G.N. Lewis and Courcelle. So why the sodium chloride has chemical formula NaCl instead of NaCl2. Why water has a chemical formula of H2O, not HO2? So this we are going to discuss today, right? In this concept of here, what type of formation may occur? What type of formation may occur that we are going to discuss, right? This is suggested by G. and Lewis, G. and Lewis and Kossel, Kossel, in 1916. In 1916, these two famous chemists they suggested that because atoms is not stable at all. So they want always this magic configuration. They want always this magic configuration, either losing electron or by gaining electron. Either losing electron or gaining electron. Because by the time no successful theory was prescribed. So that's why this is believed to the first theory about the chemical bonding. Of course, there are several theories, there are several shortcomings present in this theory, that it is believed to be the first theory about because there is small justification about this octet configuration and duet configuration. So they suggested that certain elements like metals they have a tendency to lose electron, whereas non-metals they have a tendency to gain electron. And this losing, gaining, all are intentions or main intention of this losing and gaining to achieve this inert gas configuration. Achieve this what the inert gas configuration. Right? So that's why everyone want to you achieve that inert gas configuration either duet configuration or octet configuration. Okay, either losing electron or gaining electron. Now coming to the periodic classification. Coming to the periodic classification. So in periodic classification, we have several groups are there. So I kept that's why periodic classification on your screen, right? Because it is based on the periodic classification. That's why I'm putting here how the combination is taking place. Let us understand here, right? Okay. So in this periodic classification, you can observe what are the various group elements. So first column, that is CO1A, which we call as alkali metals. Alkali metals. Which is the group valency. What is the group valency? Already we got. So what are the elements are present? So except hydrogen. Hydrogen you can include, but it is not a metal. It is not a metal. So we can take lithium. What is it? Lithium, then sodium, then potassium, then your what is rubidium, cesium, right? Rubidium, cesium. These are the alkali metals. And their electronic configuration, if you observe here, this is a 2s1, this is 3s1, this is a 4s1, this is a 5s1, this is a 6s1. So they have last electron enter into s orbital, that too only one electron are there. That's why these elements have a tendency to lose electron. How many electron? One electron. They have a tendency to lose one electron to form. What it will form? Now Li plus, next Na plus, then K plus, then your rubidium plus, then cesium. I mute. Okay, so they have your tendency to lose electron. That's why they got a valency of plus one. They got a valency of plus one because they have a losing tendency. Okay. Similarly, if you talk about the second A, if you talk about the second A, this is called your alkaline earth metal. Alkaline earth metals. Right. So under this alkaline earth metals, what are they? Now, one is your beryllium. Of course, it is not a metal. Okay, partially it is a metal. So beryllium. Next, magnesium. Next, calcium. Next, strontium. Next, barium, and radium. What? Radium. So radium is radioactive. So leave about the radium. Okay, leave about the radium because it is radioactive. Okay. So what is the general outer electronic configuration? The general outer electronic configuration of these elements are, what is that? Now 2s, 2, next 3s2, next your 4s2, next 5s2, next 6s2. That means they have two electrons in their outermost. Two electrons in their outermost. So they have, because these electrons are present far away from the nucleus, that's why they have a tendency to lose how many electron? Two electron. Lose the two electron to form what they will form? Now Be2 plus, next Mg2 plus, Mg2 plus, next Ca2 plus, next strontium 2 plus, barium 2 plus. So they are used to form your plus 2 ions or dipositive ion. Dipositive ion. That's why group 2A has a group valency that is your plus 2. That is your plus. Okay. Coming to group 3. Coming to group 3. This is called the boron family. This is called the boron family. So let us talk about the boron family. Right. So what is the boron family? The boron. So next is your the 3A. Third A. That is called boron family. Boron family. Right. Because it is starting with the boron. So coming to boron, next is your aluminium, gallium, indium, aluminium, gallium, indium. So all these are elements. What is the general configuration? A general configuration you can find here 2s2 2p1, 2s2 2p1. Next 3s2 3p1. Next 4s2 4p1. Next 5s2 5p1. So they have three electrons in their outermost. They have three electrons in their outermost. That's why these elements have a tendency to lose three electrons. How many electrons? Three electrons to form the corresponding ion, and that is your D3 plus. Next, Al 3 plus, Al 3 plus. Next, gallium 3 plus. Next, indium 3 plus. Right. So that's why your this third A group has a valency of a plus 3 because they have a tendency to lose electron. They have a tendency to lose electron. Okay. Coming to next is your fourth. So they have a valency 4. Okay. So we are not discussing because this carbon family does not participate in this donation and receiving of electron or gaining of electron. They don't have a tendency. So coming to the next one, that is your fifth A. That is your fifth A. This is called nitrogen family. This is called a nitrogen family. So in this family, nitrogen is the first member. Nitrogen, phosphorus, arsenic, antimony. So all these. So nitrogen. Next is your phosphorus. Next is your arsenic. So let us take only three members here. Okay. So what is the configuration will come? The electronic configuration will be 2s2, 2p3. Next, 3s2, 3p3. Arsenic will be 4s2, 4p3. So you can observe here that they have electron 3 plus 2 equal to 5. 3 plus 2 equal to 5. And we have a different type of electronic configuration. What is that configuration? Now, either they have a one electron or two electron or three electron. So your the the general outer electronic configuration or GOEC, or we can say the number of electron present in the valence shell. Present in the valence shell. So it can be, you know, already I told what is the valency, already I told. If it is less than equal to 5, it is nothing but the group number. It is nothing but the group number is the valency. Right. And if it is a greater than 5, then your 8 minus group number. 8 minus the group number is nothing but the valency. Right. That is nothing but the valency. So here you can observe here we have 5 electrons in the outermost. As it has a 5 electron, so valency is a 5. And these 5 electrons are more close to the nucleus, more close to the nucleus. That's why these elements don't have a tendency to lose electron. Don't have a tendency to lose electron. They have a tendency to gain electron. They have a tendency to gain electron. Right? So that's why these elements, what they will do, they will gain electron. Nitrogen has a gaining tendency, not the losing tendency. Nitrogen has gaining tendency of electron, not losing tendency. So these elements, what they will do, now these 5 electrons are there, 8 minus 5. So they need more 3 electrons for octet configuration, which is our magic configuration. So what they will do? Now they need the 3 electrons, right, to form your N3 minus, next phosphorus 3 minus iron, arsenic 3 minus iron. So that's it. The group valency of our nitrogen family is your minus 3 because it needs 3 electrons. It needs the 3 electron for octet configuration. Okay. Coming to sixth, coming to sixth A group, that is your oxygen family. That is your oxygen family. Starting member is oxygen. Oxygen, sulfur, selenium, tellurium. So I can write oxygen. Next sulfur. Next is your selenium, selenium and tellurium. So these are the elements present under this. So here you can observe the oxygen configuration is 2s2, 2p4. Next 3s2, 3p4. Next your 4s2, 4p4. Next 5s2, 5p4. Right. So they have how many electrons in their outermost? They have 6 electrons in their outermost. 8. Vidyashree, my dear Vidyashree, mute yourself. Okay, so they have 6 electrons in the outermost. So for the magic configuration of octet, they need 2. That's right. They have a tendency to gain 2 electrons to form O2 minus, next S2 minus, next selenium 2 minus, and tellurium 2 minus. Right. So it's a group valency is how much? That is nothing but equal to minus 2. Similarly, if you talk about the next group, what is the next group? That is called 7th A group. 7th A group. So this is your 7th A group. That is called halogen family. This is called halogen family. In this, what are the elements are there? Now, fluorine, chlorine, bromine, and iodine. These are the four elements are present: fluorine, chlorine, bromine, iodine. So fluorine, what is the configuration? I say one more electron you add means 2s2, 2p5. Next is a 3s2, 3p5. Bromine 4s2, 4p5, 4p5. Iodine 5s2, 5p5. So they have how many electrons? 7 electrons in their outermost. 7 electrons in their outermost cell. So they need only one more electron. They need only one electron. That's why these electrons have a tendency to gain one electron to form your what they'll form F minus, then Cl minus, then Br minus, then iodine minus. Got it? So, zero group has a no valency because they don't have any tendency to either lose electron or gaining electron. So, we got here the different group has different valency. So, let us write all these group valency at one place. What is that? Now, we need the inert gas configuration. So, that is where the group 1 has a plus 1 valency, group 2A has a plus 2 valency, group 3A has a 3 valency plus 3 valency, and group 5 has a minus 3 valency, and group 6A has minus 2, and halogen has group valency is a minus 1. Minus 1. So let us write all these points. So what they'll do? Let us find here. All want the inert gas configuration. So I'm writing here 1A group as group valency of plus 1. Right. 2IA plus 2. Third A plus 3. Right. Coming to what the fifth A. Fifth A minus 3. Sixth A, that is a minus 2, and seventh A. Seventh A has a minus 1 valence. Vidisri, do not unmute yourself. Thank you. So here the group valency of every element. So if I am taking your one element taking from X, one element X is taken from 1A. So it has a tendency to lose how many electrons? Now only one electron. Only one electron. So when it combine with the element, so how it will combine? How it will combine? Because it has a tendency to lose one electron. So first it will look who has a gaining tendency of one electron. That means the Y element we can take from your this seventh A, seventh A, because seventh A element has a tendency to gain one electron. So that's why this combination is possible, which is from your X should be from 1A, it should be from 1A with your Y element should be from, Y element should be from the second, not second, seventh A. What is that? The seventh A, that is your halogen family. And there will be an 1:1 ratio. 1:1 ratio. Then the chemical formula will be here as XY because it is contributing 1. So this X is donating 1 electron, Y is accepting 1 electron. So the compound formation will be XY. So one of the examples I can take here that X means 1A, that is Na. So if you take Na here, and this is a fluorine. So 1:1 ratio, so it will form NaCl. So that's the question what we started our topic. Why the chemical formula of NaCl is or sodium chloride is NaCl, not NaCl2, because it is 1:1 combination. So 1A require only one element from 7th A. So 1A required only one element from 7th A. So if 1A will combine with other, 1A will combine with the other. Let us say I take an X element from 1A, from 1A. Suppose it want to combine with this. It want to combine with this. So here the sixth A group has a tendency to gain two electrons, whereas 1A has a tendency to lose one electron. So that means 6A, if it want to combine with first one, it needs the two element of 1A. That means 2X is required. It required what? 2X from 1A, from 1A required, along with what now your Y is required. Y is required from which element it is? The sixth A group. And what is the ratio here you can observe? The ratio is a 2 is to 1 ratio. 2 is to 1 ratio means two element of first A group and one element from sixth A group. Sixth A group. Then only what will be the chemical formula here? The chemical formula will be X to Y. Like one of the example you can take. Jayashree, how many times I have to say? Hey, don't disturb, please. Okay. So when two elements are taking, like example, either H2O. So here hydrogen is there. So hydrogen and oxygen here. So oxygen requires two hydrogen. So that's it. Two hydrogen required. The ratio is 2 is to 1. That is your H2O. H2O. Right. So this is the chemical formula is coming there. Okay. Now if you take some more elements like that, if I take the different element like that. So what will be the combination? Let us find. So if I take the second, let us take your this combination. So what about this combination? So this is second A. It has a tendency to lose two electrons. So first it will look which has a tendency to gain two electrons. That means these elements are possible. So if I take X element and Y elements, if I'm taking the combination, X is from second A group and it needs the one element from the sixth A. One element from sixth A group, and there will be a combination of 1 is to 1 combination. 1 is to 1 ratio, then it will the form will be your X and Y. The chemical formula will be X and Y here. So, for example, if I am taking here magnesium and here oxygen, so what is the ratio? 1 is to 1 ratio. 1 is to 1 ratio. That's the formula will be MgO. Formula will be MgO. If you take calcium, so calcium with oxygen, that also 1 is to 1 ratio. So it will form CaO. So this is the chemical formula of CaO. Right. Similarly, if I combine this one with this 7th A, so it has a tendency to lose two electrons, it has a tendency to gain one electron. So that's a second A group required, second A group require two elements from 7th A. So if there is a combination between X and Y, and X is from second A group and Y is from 7th A group. 7th A group. So this is valency is 2, this is valency 1. So it needs how many? Now two combination means 1 is to 2 ratio. 1 is to 2 ratio. The chemical formula will be XY2. XY2 formula. So like if you take second A means magnesium, right? And this is a chlorine if you're taking, this is your chlorine if you're taking chlorine from 7th A. So the ratio will be 1 is to 2 ratio. So it will form MgCl2. It will form MgCl2. Right. Calcium with chlorine. it will form 2 ratio. So it will form CaCl2 calcium chloride. Right. So this is the various combination possible. So if you take about the same third A, so third A will combine with the fifth A with 1:1 ratio, with 1:1 ratio.